All right, guys, what's up? Daddy here today, and we're going to be looking at the best GPUs for 2025. And I did a video in the past, or I did a video last year with the best GPUs for 2024. So I figured I would remake one this year, and this is particularly special because I just finished version 1 of my website, thedatadaddy.com. And in this website, we have a GPU comparison tool. One of the comments on the last video was that people wish they could have this in real time, and I thought about going back and updating the spreadsheet, and it was clear to me that that really wouldn't be that helpful because it would be quickly outdated. So we really needed some kind of a real time tool to evaluate the GPUs and how the price versus performance changes on a day-to-day basis. So that's what this tool aims to do. So when I say real time, it's not minute or hourly, but it is daily. So it actually goes out and scrapes the prices from eBay for these GPUs, so you can get a real-time update and see what the price performance is for these GPUs on a daily basis. So let's start by just going kind of over how this works and how you might want to use it, and then we'll get into some analysis as far as what the best ones might be for your use case. And I'm going to look at machine learning and deep learning in general, and then with regard to LLMs, and then stable diffusion, which are kind of more intensive applications. And that'll be kind of the avenues. So whichever one of those you want to go, I'll try to recommend things that will be the most useful to you. So first thing here, guys, is the bar at the top. This is kind of like the menu bar, will allow you to sort and control what you're actually looking at. So first thing here is, do you want to sort by ascending or descending? So right now it's by default, it's set to composite score. So I'll explain what that is in just a minute. And then the single precision, or FP32. And then we're going to use the price performance. So there's also a just pure performance indicator. And then what kind of price are we looking at? So the median price or the best price, and I'll also explain those in just a minute as well. And then for the composite score, it looks at a weighting. So for example, do you care most about performance? Do you care most about VRAM? Do you care most about bandwidth? And this is what I kind of set as default. So 0.4 for performance, 0.4 for VRAM size, and then 0.2 for bandwidth, because that's just what I would look at if I was considering these things. So by default, you're going to pick a sort ordering, and then you're going to pick a value. So you can also pick for this composite score that I just talked about. You can pick the GPU name. You can pick the median price of a particular GPU, and then the best price, and then the FP16, 32, 64, VRAM if you want, and then bandwidth. And I'm going to expand on this later, but I felt like this was kind of a good place to start. So that's why I chose all of these things. These are what I consider to be some of the most relevant factors when you're considering what GPU to buy. And if you want to know more about my methodology and selecting GPUs, that's in a previous video, and I'll link that in the video description, so you guys can kind of get a more in-depth overview of how I think about choosing GPUs. And I'll also make a section on the website about how to choose a GPU at some point in the future. I just haven't had a chance to do that right now. So basically the choices are, you can select the sort ordering, you can select the value, and by default it's this composite score. So these are kind of self-explanatory, but the composite score I'll explain a little bit more here. So by default, like I said, it starts with single precision, it starts with a price to performance, it starts with the median price, and then it starts with these weights. So the way that these are all calculated, these are basically the performance of the theoretical performance of each GPU gotten from various data sources and cross-reference between what NVIDIA says, from Tech PowerUp, from Wikipedia, from all these different sources to compile the most accurate that I can find as far as the theoretical performance of these GPUs in terms of floating point operations. And then we have the score itself. So I wanted to be able to give you the opportunity to compare price to performance, and then just performance only. So if we select performance, it just goes down here, and you can see that now we're going to go and we're going to be looking at GPUs like the the latest and greatest, like RTX 6000, and then the L40, and then the H100. Those are all obviously going to have much better performance than some of the older GPUs. But if we switch back to price performance, we can see that you actually get a lot more bang for your buck if you look at some of the older GPUs. And we'll get into what you should consider here in just a moment. By default, we're looking at price performance. We're also looking at median price. So you can also do best price if you'd like. I think it's more practical to do median price just as it gives a more fair comparison. Some GPUs may be on sale, some may not, but the median prices should be a pretty good way to benchmark the GPUs against each other. And then for this performance, this is talking about whatever floating point type that you've selected, and then the amount of VRAM, and all this is scaled against the best. So it is max scaled, meaning whatever the maximum here is, like the maximum value, it's scaled against that. So you get like a percentage, and then these percentages are weighted and then scaled again to come up with this price composite score. So basically, the way that I like to think about things is I want 40% weight towards performance, 40% towards VRAM, because I think VRAM is particularly important in this day and age as models get larger and larger and larger. We really want to make sure that we consider VRAM is a big part of our factor, and then bandwidth is also important to consider, but I think it's less so. Just from my empirical testing, I think that's probably a good weighting. But for example, if you only care about performance, you can just move this up, and this is going to tell you that you need to make sure everything sums to 1. So, but yeah, if you only care about performance, then you can go weight all the performance. If you only care about VRAM, you can do the same thing. But just by default, I have everything set to 0.4, and then 0.1. The next thing we need to talk about is how are these things actually calculated? So the median price, what it does is it goes and scrapes the first 50 values for each of these GPUs. So it takes the first 50 values, it cleans them for all the stuff and garbage that's not really actually related or that's wrongly named, and then it takes the median value. And then, so I use median because it's less skewed. Typically average skews on outliers high or low. So you get, I think, a more accurate sense of what the price, what the normal price for this type of thing would be by looking at the median. And then also I look at best. I have some heuristic algorithm that I've been working on to actually figure out, what's the best price GPU based on reviews and price and the number of reviews and things on eBay. So it's pretty accurate. I'm working on making it better, but for right now, the best price and median price are taken from the best 50, or the first 50, I should say, values on YouTube, and then cleaned and processed into the best and median price. So that's how I'm getting all this data. The next thing before I actually start going over these GPUs, I just want you to know that you have this full info available. So if you want to dig more into all the particular specs for a GPU, you can bring this up, and it will go through, all the general information from the architecture to the processor size, or the process size. Does it have NVLink available? What is the generation? Has the clock speeds. It has additional information as far as how large is it in terms of slot width, TDP. Does it have any video output? What are the power connectors needed? All these things I thought would be relevant when you're making a decision about whether you want to buy a GPU or not. I tried to make this available for you. And then performance rates, of course, this just gives you a little bit more information, things that may not be as relevant to machine learning. But if you're also interested in gaming, for example, these might be relevant to you. And then, of course, memory specifications. So what is the VRAM type, the size, the bus width, bandwidth, etc. And then more specific compute, and then tensor cores if you're interested in that, and then L1 and L2 cache, etc. So all this information is here for you. And then also I have made it so that you can look at price over time. And I think this is neat because it allows you to see, okay, how are the prices trending? Is now a good time to buy? How is this price versus the median price? So it can give you more confidence that you're buying at a good time and that you're buying at a good price for each particular GPU. And then I made it so you can go back and look at the last week's price history, and you can actually link out to eBay, to go see what the best price was, or what the best price GPU was at that particular time. So this should help you, if you are interested in buying one, this should make it easy for you to find a good price on a particular GPU. And I do just want to highlight that these are all affiliate links, which help me out, but they don't cost you anything. So if you are going to buy, it would be great if you would consider buying through one of these links provided. So I just wanted to be clear that these are affiliate links, but it's not going to negatively impact you in any way if you use these to purchase a GPU. Okay, cool. So, and I guess the last thing is you can also filter these. So if you'd like to look at a particular time frame, you can select this, and then just look at a smaller time interval. So all those things are there available for you. Okay, so now with that stuff out of the way, let's get into the GPUs that I would actually recommend, or that I recommend is a strong term, that I think are good to consider in this particular day and age and in this environment, and then for whatever your particular use case is. So I'm going to start speaking just in general at GPUs that I would consider for just generic or general deep learning. Think about everything from running LSTM to maybe a ResNet model, or BERT, or some of these like standard deep learning models that are popular and that are integrated into a lot of different things. So that's what we're going to address first. If you just want to tinker and you want to do projects with that kind of thing, here's what I would recommend. And obviously, if that's your goal, I would start on the just standard default settings, and I would go down the list, and I would look at the K40. I would look at I don't like GPUs that have that are like dual GPUs, or there are multiple GPUs packed into one. So for example, if you see this ×2 here, that means there's actually 2 GPUs that are smashed into a single one, and I don't like that, so I would probably skip it. And you can go down the list and see what kind of price to performance ratio that you actually get. And if you'll notice, a lot of the first GPUs that are recommended are these Kepler series GPUs. So one thing that's important to consider, and a lot of people are going to be like, how can you possibly be recommending Kepler GPUs? And I am, but with some caveats. So just from a pure price to performance perspective, you're going to be hard pressed to basically get the same level of performance, price to performance, purely speaking, than you get with these older architectures. The Kepler series, the Pascal, Maxwell. This is where you're going to find the most value. Now, whether this works for your application and your use case, that's a kind of a different question, but you are going to get the most price for performance here. And one thing I want to touch on while we're talking about all of this is this, basically the NVIDIA driver support. So if you come up here, and this is end-of-life.date NVIDIA GPU, and to be honest with you, this seems reputable. I'm not 100% sure who maintains this, but this is one of the best, easiest ways I could kind of get a sense of what is supported and what's not. So I'm going to share this with you guys. So take this with a grain of salt and take this for what you will. But as you can see, a lot of the newer architectures, these are supported. They're in production. Obviously, they have active support and they have security support. So, and they will probably be for the foreseeable future. But as we go down the list and we look at Ampere, we look at Turing, and then we look at Volta. So now we see that these are no longer being produced, but they're still supported with active support and security support. So, and all of those were supported all the way down to Maxwell. Okay, so this is the last officially supported architecture by or so I guess you could say, yeah, architecture supported by the drivers by NVIDIA. So Kepler, as we've seen, is no longer supported. Actually, support ended 3 years ago. So it's no surprise that these are very cheap, and they're probably at the top of the list because they're not officially supported by NVIDIA anymore. So if you are going to go this route, just understand that at some point you may run into issues. I've never had them, and I've known a lot of people that have used these GPUs for various things that if you're using, especially if you're using an older driver, like you can use these no problem. So I think for a lot of people, if you're just looking to do general, deep learning and machine learning, you can find a lot of value here. And, some people will argue with me about this, and that's totally fine. I'm simply saying that if your goal is to work with fairly simple and smaller general deep learning models, I think there's still a lot of value here. And then one thing I would say is if you were, this scares you and you don't like the Kepler architecture, well, you can just go down here and you can search C or K, and you can deselect all these GPUs, and then you don't have to look at Kepler anymore. You can just look at what's next. And surprise, surprise, that's the Maxwell series GPUs. And you can pick one of these, or you can scroll down a little bit further and you can start looking at some of the RTX series, the 200 and 300, and then you should see the Pascal coming up here as other fairly decent choices. So anyway, that would be my recommendation. And then if you can find good deals, that would be a big driver. I'm not like a diehard, this is the best GPU. I think it all depends on what is the price to performance. So sometimes there'll be great deals and you can get, great GPUs for a good price because you're getting them on sale. So I think that's always something to consider. What I would say is I probably wouldn't, in this day and age, I probably wouldn't go below like 12, I think is a good benchmark, or like somewhere in that, 8 if you get a really good deal, but somewhere 8 to 12 for generic deep learning, if you're doing those kind of things, I think would be fine. I would always err on the side of going larger. I think, larger VRAMs more VRAM is always better, in my opinion. So I would actually choose that over better GPU performance. So that's, my 2 cents. And everybody's different and your applications are all different, but I would say in general, that's how I would approach it. And then the next thing I would consider is, and actually just to put some hard numbers to this, because I think that's important. And I've done some studies in the past. Like if you look at this, one of the studies I've done in the past year, this is looking at just the RTX 3090, the P100, and the P40. And these are some of my favorite GPUs where I think you really find good value for the performance. But obviously, you're going to get a lot different. The LSTM kind of skews things a bit, so I'm going to take that off. But what you can see is if you look at throughput, so this is just samples per second. And then this would be the same thing as like tokens per second for LSTMs and that kind of thing. You do get a significant performance boost when you go up to the 3090, which isn't surprising. But you still have relatively good performance from the P100 and the P40. And a lot of people ask, okay, well, what about, mixed precision and half precision, those kind of things? And certainly, you do get a performance benefit from those kind of things. So if you look at mixed precision versus just single precision, looking at GPUs that have a significant number of tensor cores, like the 3090, you do see that we get, almost, we'll call it roughly double. The performance, well, not roughly double, that's not true. Maybe like 70, 80% increase. Anyway, the point I'm trying to make is these things do play a part, but you also pay a premium for those kind of things. So again, if you're just looking for generic deep learning, you don't really need mixed precision per se. in the P100 or the P40 or some of the Maxwell series would probably be fine for your application. It really just depends on what you're trying to do and whether you actually really need this mixed performance. Or I guess you can take advantage of this FP16 or even quantized performance with like 8 and 4 and 2-bit that you get with a lot of the open source LLMs and stuff now. So these are all important things to consider. And by the way, like by default, a lot of models run in FP32. So unless you actually change things around, like for example, if you're using a TensorFlow library or you're using a PyTorch library off the bat, like for example with a ResNet or with BERT or whatever like that, they're going to be set to use single precision by default. So you're going to have to actually go in and manually change it to take advantage of this mixed precision, which, to be honest, not a lot of people really do. So, I guess my point is, before you throw out some of these older GPUs, understand that they're probably going to be fine for a lot of people's use cases. And that's, I guess, the point here I'm trying to make. In general, unless your use case dictates it, I think you really can find a lot of value in some of these older GPUs. So, and if you're interested in this analysis, and I have a whole video on it, I'll link it in the description, so you guys can check it out if you're more into it. Okay, now, so we've addressed in general, and then now another important consideration here is if you want to look at like LLM specifically or Stable Diffusion or something that in particular requires I would say a higher level of GPU so that you can have a certain level of performance. And what I mean by that is, like for LLMs, for example, a lot of times if you're building an application that you need somebody to interface with directly, like a user is going to be directly chatting with the bot or with whatever it is that you're building, then you need the number of tokens per second generated to be high enough that it seems like you're having a real conversation. Otherwise, the user experience is going to suck. So in these type of cases, you really do need to pay up for some kind of performance. So in that case, what I would recommend, and let's just take a brief look here, is I have another study where we look at all the GPUs, or the GPUs we looked at in the last one, but now we're looking at them in terms of tokens per second with Ollama. So I built, as part of the benchmarking suite we looked at with the last one. It's called BenchDaddy, and it's open source, and I'll again link that if you want to take a look. But that's what I used in the last comparison. That's what I'm using here as well. But it basically just takes a bunch of models in the Ollama library, and then we do a bunch of testing, and this is kind of the results of the testing. But what I've found, and what I think most people would agree on, is the fact that there's a minimum level of performance, like I said, that you can actually have like a real-time conversation with a particular bot. And to me, that's 10 tokens a second is kind of a extreme low-end baseline for those kind of things. So that would be one area where if you're looking to run larger models, then you might want to go with something with similar performance to the RTX 3090. So in yellow here, we have the RTX 3090, and you can see that even with like the 26 gig model, the 70 billion 2 quantized, and then the 3 quantized, and then up to the 4 quantized, almost 48 gigs, we're still getting about 16 tokens a second. So anyway, this would be suitable for somebody who's looking to kind of play around with those things. It would be suitable for you to use if you're looking for like a real-time type of experience. Now, if you don't care about that, then the P100 or P40 or whatever, these would be fine. In fact, I have 2 P40s that I'm using to run I think the FP16, this exact model here, and it's fine. I mean, I use it within, like, it's basically an API, and I have some applications that basically just send queries whenever they need it, and it's it's slower, but since they're operating as part of an application that doesn't require real-time input, it's totally fine. And they do their job, and it's no problem. So the point I'm trying to make here is it really depends on what your application is and what you need. And you can still do a lot of things with LLMs, especially in particular some of the smaller ones, with some of these lower cost GPUs. And if you're building them into an application, I think it's probably a fine way to do it. So anyway, just wanted to keep that in mind. And if we're going through here, so let's now switch over to FP16, and let's look at, let's go back to median price so we can keep things consistent. And then let's go ahead and get out of here. So let's just say that you were looking for, well, let's look in general, and then we'll look at something a little bit more intense. So let's just go ahead and take all of these coupler series GPUs out of here, and we'll start with at least Maxwell, and then we'll start going down the list. So let me make sure that I've not deselected anything else. Okay, yeah, I just had the coupler. So anyway, so yeah, we've taken the things that aren't supported by NVIDIA out of there. So that's fine. I think that's reasonable. So now the next thing is, surprise, surprise, the P100 is the best bang for your buck that you're going to get with the 16. And I can say that these GPUs work fine. My only gripe is that if you're going to be working with LLMs, the 16 gigs of VRAM is a little bit small. So I might pay up a little bit more for the P40, although the P40 now is significantly more expensive. It used to not be, but in the recent 6 months, the prices have spiked significantly on those. So that again, it may not be a good price to performance anymore, even though it used to be in the past. So some other considerations here. Again, I probably wouldn't pick anything that is for this thing, especially definitely not below 12. I probably wouldn't go below 16. So that would be kind of a threshold for me. So we'll skip some of this until we get to another GPU that has at least 16. So the T4, could be something for you. Now this has a bit heftier of a price tag, but it's got 16 gigs of VRAM, and it's got a very good FP16 performance. So in fact, this actually should perform quite a bit better than even the 3090 ASUS using mixed precision. In theory, it should do almost twice as well in terms of throughput for roughly the same price. Now, you're going to lose on VRAM there, but again, just depends on your application and what you need. So that could be another decent choice. If we keep going down here, let's see, I'm sticking to my 16 GB. Okay, here we go. Again, the 3090 is the next thing down on the list. And to be honest with you guys, I think this is probably where the best price to performance lies. If you're going to be wanting to work with larger LLMs or stable diffusion, I think I would probably buy this at this point. Another one I was considering for a while was the Titan Titan RTX. And I've actually done some testing on it recently, and it's not as good as this for the price. So I think price to performance, and I think you'll actually see here in just a second, we'll pass the RTX down here in just a bit. So anyway, this is probably where I would, if you want that real time experience, this is where I would put my money. And I would scale out with the 3090s at this point, because I think that's where you're going to find the best bang for your buck. All right, let's see what else. The M40 is another thing that you might consider because it's cheap, allows you to run bigger models. I've actually never experimented with the M40. I like that. So this is a. Let me make sure this is the case. Yeah. Okay. I just want to make sure it wasn't a dual GPU. I don't believe that it is. So anyway, this isn't a dual GPU, so it has 24 gigs of consolidated memory pool. So like that, the performance is a little bit lackluster. But for $80, you really can't argue with it. So this might be something, especially if you're looking to get in, on a huge budget. You could consider this, and this would give you the ability to play around with larger models, even if you're going to have pretty slow tokens per second overall. So another thing to consider. And then here we go. The NVIDIA Titan RTX was another thing that I was looking at. And it has similar specs, but it's just not as good in the single precision, and it has a little bit worse half precision performance than the 3090. So, and the overall composite score is a little bit less. So, I would probably not, or I would pick the other one over this. And in particular, you can find the 3090 a lot on Facebook Marketplace for pretty cheap, because it's also can be used, or also is used a lot for gaming. I know the RTX is too, but I think the other one's a bit better value there. So yeah, guys, that pretty much does it for this video. Those are my recommendations. And the same recommendations for me pretty much go for Stable Diffusion as well. Although you could probably lower the VRAM consideration there, maybe to 12 or less than 16. You can be less stringent on that because the model sizes aren't quite as large. So maybe you can prioritize performance over VRAM in those cases. But yeah, guys, so that's where we're at. And then to recap, I would say that whenever you're just looking at general, I think that looking from the single precision and then just kind of going down a list in best price performance and seeing what fits your use case is a good way to go. And then for LLM specifically, I think the 3090 is probably where you're going to find the best bang for your buck at this point. So, all right, guys, that's it for this video. I really hope that you enjoy this tool, and please leave any comments or suggestions here as how I can make this better. I've already thought of a few. I think that adding a way to kind of filter these out a little bit better is in the works, and it's needed. So I'm adding that. But at this point, I think the tool overall gives you a lot that you can already experiment with, and then it will help you significantly in trying to narrow down, what is best for your money at this point with regards to GPUs for machine learning. So anyway, guys, hope this video was helpful to you, and please leave your feedback in the comments, and I will see you in the next one.
All right, guys, brief reminder here. If you enjoyed the content, please consider giving me a like and a subscribe so I can continue to grow and produce better and better content for you. If you really enjoyed the content, you might even consider buying me a coffee, and the link for how to do that will be in the video description below. If nothing else, please just give me some feedback in the comments and let me know how I'm doing, if anything's unclear, or if there's anything that I can improve on. Thank you again, guys, and have a great rest of your day. Bye-bye.